Hey guys, this is Mrs. Rooker. Today we are going to be doing just the first little section of 2.5 on this video. So I'm going to have you start with the review questions. So review questions 1 and 2. So do these on your own, pause the video right now, and then we'll go over them together. All right, so number 1 says state the possible rational zeros of that function. So when we do this, we do the factors of the constant term over the factors of the leading coefficient. So all the factors of 7. This one's pretty quick and easy because there's only a couple factors of 7. That's positive or negative 1 and positive or negative 7. Plus or minus 7. And then same deal with 3. The factors of 3 are just plus or minus 1 and plus or minus 3. Because both 7 and 3 are prime, they only have a couple factors. So now we're just going to do, kind of write these all out. So that would be 1 over 1, which is 1 over 1, which is 1, so plus or minus 1 is one of the factors. Then I'm going to do 1 over 3, which is 1/3, so plus or minus 1/3. So that was 1 over 1, and then 1 over 3. Now I'm going to do 7 over 1, which is just 7. And then 7 over 3, which I'm just going to leave as 7/3. Those can't be simplified further, and that is all the possible combinations. So those are the only possible rational zeros of that function. That doesn't mean that all of these are going to be zeros, that all of them are solutions, because you can see here, here, it's 3rd degree, so there's only going to be a max of 3 real solutions. But these are possible ones that you could try using synthetic division to see if they are real solutions of that. All right, moving on to the next one. Find all the zeros of this function. So you could type that into a graphing calculator, and that'll give you a good idea of where the zeros are located, where it crosses the x-axis. But for now, I'm not going to do that. I'm going to use the possible rational zeros and guess and check. That's a little longer, but that's what you're going to have to do if you don't have a graphing calculator with you, or if it's a non-calculator test. That's what you'll have to do. So the nice thing is -2 and 1 are both prime, or, well, yeah, -2 and 1 both don't have many things that go into them, so that'll make that easy. So plus or minus 1 and plus or minus 2, 2 are the only factors of 2. And then we're supposed to put that over 1, because 1's the only factor of 1. But if you put them over 1, they're still just 1 and 2. So positive and negative 2, positive and negative 2, positive and negative 1 are the only possible rational roots for that function. So I'm going to do synthetic substitution. 1, 1, -5, -2. And then I'm going to guess that maybe 1 is a solution to this system. I always start with 1 because it's the easiest. All right, bring the 1 down, multiply and add. Multiply and add, we get -3. Multiply, we get -3. Add, we get -5. What that means is this is not... 1 is not a solution to that, 1 is not a zero to that function. So I'm going to start over with, I'm going to do -1 next. Just because that seems easy to me. -1, add, we get 0. Multiply, we get 0. Add, we get -5. Multiply, we get 5. Add, we get 3. Again, not a solution. So -1 and +1 are both not solutions. So let's try again. Now I'm gonna do 2. Hoping this works because I don't want to do this 4 times. Multiply, we get 2. Add, we get 3. Multiply, we get 6. Add them, I get 1. Multiply, we get 2. Add, we get 0, which is awesome. That means 2, +2, is one of the zeros. So x equals 2 is a solution. What we have left is a polynomial to the 2nd degree that we can try and factor to solve. So we have x squared plus 3x plus 1. But nothing multiplies to give us 1 and also adds to give us 3, which means this isn't going to be factorable. So I am going to solve this using the quadratic formula. So remember, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So plug in 3 for your b. So -3 plus or minus 3 squared, which is 9, minus 4 times a, which was 1, times c, which is also 1, all over 2 times a, which is 1. So it'll just be 2 on the bottom. All right, keep going. -3 plus or minus, I'm just going to simplify this whole thing. This is 4 times 1 times 1 is just 4. 9 minus 4 is 5 over 2. And 5 can't reduce, root 5 can't reduce, so we are done here. This is our other 2 solutions. So that's 2 solutions there, 1 solution there. That's all 3 of the zeros for that function. Okay, so for this video, we are just focusing on Descartes' rule of signs. So that's what we're going to do for example number 1. All right, so we have this example here. And it says, since the degree is blank, there must be blank solutions. So the degree of this polynomial is 4, because the largest exponent is 4, which means we must have 4 solutions. But not all of those are necessarily going to be real solutions. We will have some real, potentially some imaginary, we don't know, and we will maybe have positive solutions or negative solutions. And so Descartes' rule of signs helps us to determine how many positive solutions we'll have and how many negative solutions we will have. So the rule of signs says that the number of positive solutions is determined by the amount of sign changes in the polynomial. So what I mean by that is we're going to see, when this is in standard form, how many times it goes from positive to negative or vice versa. So this was positive and this was negative, which means there was a sign change there. That was 1 sign change. Then we move to the next 2. This is negative, that's also negative. That's not a sign change, it stayed the same. But then from the -5x squared to the 8x, it goes from negative to positive, which is another sign change. Then the last 2, from +8 to +4, they stayed positive, so there was no sign change, which means there's only 2 sign changes, which means there must be 2 or 0 positive real solutions. So when you're determining how many positive solutions are, you count the sign changes, so we had 2 of them, and you always do that number, and then you count down by 2, and that'll be your other option. You keep counting down by 2. So for example, if there were 4 sign changes, there would be either 4 positive solutions, 2 positive solutions, or 0 positive solutions. So you always count down by 2. All right, moving on to find out how many negative real solutions we have. we find f of negative x. So what I mean by that is we're going to take the original function and we're going to plug negatives in negative x every time you see an x. Oops, negative x, not negative 8. All right, now we're going to simplify. Negative x to the 4th power would be a negative times a negative times a negative times a negative, an even amount of times, which is going to become positive. So that's just going to be positive x to the 4th. I'm going to write this down here, actually, so I have more room. So this will be positive x to the 4th. Then this one, a negative to an odd power stays negative. So this will be negative, but there was also a negative in front, so negative x to the 3rd times negative 2 is going to be positive 2x to the 3rd. Then this one, a negative to an even power becomes positive, so this becomes positive x squared. But there was a negative 5 here, so negative 5 times positive x squared is negative 5x squared. All right, and then the next one, negative x, there's no power on here, so it's just 1. Negative x times 8 is negative 8x, and then the positive 4 just stays as is. So what happened here was basically the odd powers went from being negative to becoming positive, or vice versa. The odd powers ended up changing because we plugged a negative in there. All right, now we do the same thing as we did with the positive solutions. We're going to count the amount of sign changes. This is now going to determine how many possible negative solutions we have. So positive to positive, no sign change. Positive to negative, that's a sign change. Then negative to negative, no sign change. Negative to positive is another sign change, which means we have 2 sign changes, so there must be 2 or 0 negative solutions. Unfortunately, on this one, we didn't have any that had, for example, 3 sign changes. If you had 3 sign changes, that would mean you have 3 or 1 negative solutions or positive solutions, depending on if you did it with the original or with the negative version. So basically, the amount of sign changes and then subtract 2. And that'll be the amount of possible positive or possible negative solutions. All right. One more part. Descartes' rule of signs. Look at the sign changes of f of x to find the number of positive real solutions, and look at the sign changes of f of negative x to find the number of negative real solutions. Always go down by 2 when counting. So, for example, let's say when you were looking at f of x, there were 5 sign changes. That means you would have 5 positive solutions, or 3 positive solutions, or 1 positive solution. There's no way that you'll end up with just 4 positive solutions, for example, on a problem that has 5 sign changes. All right, so that is it for this lesson. Make sure to take notes. Make sure you took notes. Bring those notes to class. And thanks, guys.